I've got a nice big pile of electronics here that have lots of parts in them. Today I'm going to show you just how easy it is to salvage some of those parts. Welcome to Hack-A-Week. Well, we might not get as brute force as the old sledgehammer, but what we will use is some desoldering aids and some know-how and screwdrivers and such to get inside these things and pull out some components. There's lots of stuff that can be salvaged in electronics all over the place. Anywhere you find them, grab them if you're into the hobby, bring them home and tear them apart. Pull parts off from old circuit boards. I do it all the time. I've salvaged plenty of stuff. In fact, that's how I got my start playing around with electronics, was finding old ones and pulling them apart and figuring out how to use the components. So let's see what we've got here. This is a pretty cool pile of stuff. It's a pretty broad variety of things. There's a signal generator right here, an audio generator. It doesn't work. I just want to open that up and see what's going on with it. I recently got some more vintage electronics goodies. I got some old Heathkit stuff, which is kind of cool. In fact, somewhere back there is that Heathkit analog scope we're going to tear into sometime soon. So what have I got? On the top here, I've got a digital volt ohm milliamp meter. How's that for a mouthful? And who made this? It's got a resistor chart on the top. Heathkit. It's a model EF2. And, well, the LED driver or the LEDs themselves have pretty much gone away. Hardly any of the elements light up when I plug it in, but I'll give you a little more of a close-up of what's going on with that one. It's kind of cool. One of the early ones. I remember in the 70s hanging out in some music stores that actually did repairs in the back, sold electronics, and I would go hang out with some of the techies and bug the hell out of them, and some of those guys had digital meters up on their workbench like this, and that was really cool. I mean, you were pretty awesome if you had a digital volt ohm meter back in the 70s. So we're going to open that up just to see what's going on inside it. Same thing with the audio signal generator. Then I've got a couple of old cassette mechanisms here. I'll show you some goodies on these that can be salvaged for all kinds of things. I mean, it's a mechanical device, so there's little mechanical bits that can be very handy, repurposed into something else. Roomba vacuum cleaners. I don't have a whole one here, but as you know from my videos, if you've watched them before, there's lots of stuff I build. In fact, last week, the little motor that drove the little widget that made the tremolo work was a Roomba vacuum motor, a little teeny one. There's sensors in these things. There's a main board that has a nice H-bridge that can be tapped into. Motors, all kinds of stuff like that. I want to get back into like some of the old 70s, 80s electronics. The ones that were not pick and place. These were actually put in there and soldered in place by somebody on an assembly line. Maybe some of it was automated, I'm not sure. But anyway, this is all stuff that can be desoldered and reused. Capacitors, transistors, resistors. I pull resistors out of these boards a lot. Some of the really oddball ones that I don't have in the book, in the drawers. This thing down the bottom of everything here is an old Pioneer audio video amplifier, and it went bad. It's probably in the power supply system. It does absolutely nothing when you turn it on, and the fuses are all okay in the power supply, so I'm assuming that it's somewhere around the transformer perhaps went bad in it. It was ridden pretty hard and put away wet, let's put it that way. Maybe even had a beer or two spilled in it at its time, who knows, but we'll get in there and see what kind of things we can salvage. So enough of this yakety yak. Let's get out the screwdrivers and the pry bars and get to work. So first up is the Heathkit digital volt ohm milliamp meter, and you know, I was wishing I had some leads for this thing. It's got the guy's name on here who used to own it. That's pretty wild. Dan Ray. How about that? What's this? Oh look, test leads. That's pretty cool. So back to the front, let's hook up those test leads and see what we get with this thing. I think the analog readout, as simple as it is, does work. So let's see here. Let's put it on. This is the ranges right here, and then these are the functions. Let's put it on DC volts, 0 to 20 scale, and let's check a 9-volt battery out. Let's see what we get. See if anything comes up on the analog scale. No, it just doesn't seem to be doing much of anything. Let me try twisting some dials. This is tricky holding all this together. That's in the off position. Yeah, I don't know. Well, anyway, let's tear it apart. So how does it come apart? Well, what you do first is you look at the outer case and you think, well, how is that held on? Let's look around. Pretty simple on this one. There's a screw there, one here. On each side, same thing is going on. And it looks like the one here is slotted so that if you remove this and only loosen this one, you can actually slide the top cover forward and off. These screws out of here. Make sure it's unplugged. Don't want to work on things when they're plugged in, unless of course you're troubleshooting and you know what the hell you're doing. Okay. Wow, there are some big ass batteries in here. Look at that, big old D cells. Oh, that's not going to be pretty when we get those out of the way. Wow, these are ancient. What the hell are these? Look at this. Rechargeable heavy-duty industrial battery. When was the last time you saw one of those? Like, never. I've never seen these. NiCads. Now there's a dead technology. Well, at least they didn't leak all over the place. That's the nice thing about the NiCads, I suppose. But I could put D cells in here, just regular D cells, and it would work. Permacell. Well, maybe not so much, huh? Not forever, anyway. Yeah, we can put some other D cells in there at some point. Doesn't look too terrible. So this I'm not going to tear apart or do anything with just yet. Because I want to put batteries in it and just see if I can make it work. It would be pretty cool to have this thing up on the shelf as a usable piece of test equipment. But anyway, I wanted to open it up and just show you some 70s technology of what made up a digital volt ohm milliamp meter. You can see what's in there. There's some transistors, just the usual plethora of stuff. There is one big old Texas Instruments, probably an EEPROM right there. I don't know. I'll have to look that one up. Maybe we'll dig up the numbers and go searching around the internet. Got some switches over here, and of course the battery packs in the back. Here's the transformer for the whole thing. Alright, well, let's put that back together and move on. Old cassette deck mechanisms. These are pretty cool. This one I might make an Echoplex out of sometime. That'll make a neat little project. Still works okay. Electric motors in these. Belts, small belt drives, flywheels, lots of springs usually. That's pretty neat. Good source for springs. This is an older one. Mostly gutted, but there's a motor there. These motors are really well built too. They're not real high torque, but they are made to just run and run and run. So if you had something where you wanted to run a motor constantly, that would be the one to use. More springs, pulleys, things like that. Pieces of metal, lots of screws. So that's what that stuff's good for. Next up, Roomba stuff. These are the motors out of the Roomba vacuum cleaners. Very cool items for doing robotics and such. Lots of things in the Roomba that you can salvage. There's some infrared sensors mounted in this bar in the front. Really cool gear motors, and a main board that's really neat and easy to hack into. You've got H bridges here and here to drive the motors. I hooked up via email with one of the techs who used to work at iRobot and helped develop the early ones, and he said that these H bridges and their overcurrent resistors that are in there are capable of driving more than just a single motor per set, because I was driving 2 motors per set. So just FYI, you can really drive the hell out of this board. And there is a project page of how to hotwire into this and utilize those H bridges on hackaweek.com. Just go on there and search Roomba. You'll find all kinds of stuff. Here we've got a technology that's been around for 40 years or more, just good old PCBs with discrete components mounted up on them. Pretty easy to see what the values are on each one of them. You can look up the number, check out the data sheets, you may be able to cross-reference, and you can salvage all this stuff. And it's all so readily available out there. If you just look around a bit, find some old electronics, hang on to the stuff, tear it down, and salvage the goodies off from it. Right now I'm going to show you how to desolder components off from a board like this. So let's say, I'm searching around looking for the resistor I want, and there's one right there. We'll do an easy one right here on the corner. And what I need to do is desolder it from the board. I need to heat up those 2 spots of solder and basically get them off from the board somehow. Well, there's a thing you can use for that. It's a desoldering braid. There you go, and it's just braided copper. That's really all it is. It's just a little filament of braided copper. It kind of reminds me of the old school slot car racer brushes that would rub against the track. But that's a whole different story there. So how you use this stuff is you put it onto the solder that you want to wick onto the copper, and then you take a hot soldering iron and hold it on there. And when it gets hot enough to melt that solder, it will wick its way. Oops, my third hand tool is a little loose here. It'll wick onto the desoldering braid and take away most of the solder that's on that little pad, and then you can just basically lift out the component if you get enough of it off. So most of that one's gone. Now I'll do the one next to it. That one's still got a bit on it. So once I get that part done, I usually just flip it over and see if I can heat it up and just give it a wiggle out with my fingers. It gets pretty hot. It's amazing how friggin' hot a little tiny component can get and still survive. So that's one way to get a component off a board like this. Another way is with a desoldering tool that's called a solder sucker. It's basically a soldering iron with the bulb up there and a tip that has a little teeny hole in it that will suck up the solder. I just love pronouncing solder the right way because it is derived from the word solid, folks, as in to make solid. So you squeeze the bulb once you get it hot and scoop, suck it up, and it just takes it right off the board. It's that easy, really easy. So let's try that out on that big capacitor right there. Looks like there's going to be a lead probably right there and right there. So let's get this one first. We'll squeeze the bulb, heat up that little pad of solder, and let go. And we just sucked it all right up. Squeeze the bulb again. This one's got a lot on it on this spot. Might take a bit of time to really heat it and melt it. There we go. And maybe just a little more heat. And that should come out of there. There we go. One salvaged. What is this thing? 470 microfarad at 16 volts. Electrolytic capacitor. Now let's see what's up with this signal generator. Sine and square wave signal generator. We need to pull the front cover off, it looks like. Okay, that's all the screws. Whoa, a lot of stuff going on here. Wow. Well, it looks like we have some old paper wound capacitors in here. None of them look like they've been leaking. I don't know if that's the problem or not, but let's flip it over. This thing is tube driven. And you know, that's, somebody took the time to actually label on the chassis just what type of tube goes where. And it's basically an oscillator circuit that's just calibrated and tuned. Well, I'm going to plug this in and be careful not to touch anything inside. And turn it on. You can see the pilot light right there lit up. Just want to make sure all the tubes are actually working okay, the heaters anyway. That lets me know that the power supply is probably okay. So that part's alright. I noticed something funny on the bottom. There's actually a lamp. There's a lamp underneath on the bottom right there. What is up with that, do you suppose? So I've got a speaker set up here. Let's see. Got the LM386 amplifier going. So there's my sine wave. Square wave. I really don't think it should be fluctuating like that. Turns out the thing is working okay. Let's see, that's on the B scale, which would be 200 to 2000 hertz. Oh, this is too much fun. Got the LM386 amp hooked up here. Turns out this thing does work after all. That little bulb on the bottom, I tightened it up, and I've got output from the thing now. I don't know. That's strange. This is the amplitude knob. And this is the different bands. Right now I'm on the B band, and I'm at about 700 or 800 hertz. The B band goes from 200 hertz to 2000. And then we can go to C, which goes from 2000 all the way up to 20K. You can test your own hearing. Let's see, can I still hear 15? Yeah, I can still hear 15K. That's pretty gnarly. I'm gonna crank it up all the way. See if it'll pick up on the YouTube video. And we're coming back down in the scale. Probably around 14, 13-ish, 10,000, 9,000, 8, 7, 6, 5, 4, 3. Where I'm told a baby's cry is centered. And there's 20. Can't hear that. I should bring the dogs in and see what they do with the higher frequencies, eh? Nah. Then we can go to this ridiculous other scale from 20K to 200K. I'm actually putting out an ultrasonic waveform right now that none of us can hear. Wow. So this is down in the lowest scale, which is 20 to 200 hertz. There's 20 times a second. That's a sine wave. Let's listen to a square wave. Ugh, that's gnarly. 40 hertz. 50, 60, 70, Hey, check this out. I was about to hook this up to the oscilloscope. Just give a listen here. I'm not even plugging these into the leads. But if I get them close to the leads, it's actually sending out enough of a RF signal, I guess. It's picking it up through the wire there. It's going through the air, folks. That's cool. Well, let's see what happens when we connect it up to the scope. I've got the leads to the amplifier just laying near the leads to the scope. That's why you can still hear it just a little bit. And you can see the waveform on the scope. That's a sine wave. It looks a little squarer on the top and bottom, but when I switch to square wave, you see that those up and down transitions are pretty much gone. So it's a sine wave in that it's ramping up and down. Let's see if we can figure out that high frequency ultrasonic stuff. Oh, there it is. 200,000 hertz. And I have to go all the way down to a 2 microsecond sweep to get it to show up. Wild, man. Well, there you can really see the structure of the waveform. Pretty fun stuff. Well, that was cool. I think I'll be keeping this thing just as it is. Clean the junk out of it here and put it all back together. That's a handy piece of test equipment to have around for audio stuff. Now we move on to the big old stereo stuff. Most of these, it's going to be some screws around the back, maybe 1 or 2 on the side, and then the top will come off. So what's inside? Well, there's the amplifier section, the FM radio section, preamp section, and the power supply. There's the transformer. That's what I suspect went bad on this unit because there's nothing getting to the power supply whatsoever. The board over here is just dead. There's no blown fuses, so more than likely a bad transformer. These are the 2 amplifiers, left and right channels, and it's a bunch of components all put together on a slab in there and then potted and sealed all up. And that technology has been around probably since the 70s, 80s. They used to be called STK chips. They were a little bit smaller than that, and they used them in home stereo amplifiers for a long time. This hasn't got as many components going on like the other circuit board that you saw, partly because of these chips right here, but there's still lots of things on here. Transistors, I see all kinds of resistors, there's fuse holders, lots of wiring that you can salvage. The wiring is always really handy to keep. There's some RCA jacks. Back here are some speaker banana plugs in jacks. Those are handy. There's 110 volt cord. There's all kinds of screws. There's of course the sheet metal and the little bits like that. And if you just save this stuff and stick it in a drawer, then your imagination will come up with what to do with it at some point. Trust me. There you go. There's electronics to be salvaged all over the place, and not only just the electronics, but some of the plastic bits, the pieces of metal, heat sinks out of old computer towers. These are kind of handy. I used it for my desoldering sucker there during this video. And as an artist, there's all kinds of things you can pull out of all these components and use and get creative with, to sculpt with and use in your three-dimensional art, I suppose. But the point being is you can have a lot of fun playing around with electronics and design and tinkering and inventing and not have to go spend lots of money on resources. It's all over the place. Just look for people throwing away electronics, scoop them up, take them home, be careful with them. Watch out for some capacitors. They may still be charged if you see a great big one like that. The ones that are inside metal cans, like the ones in microwaves, watch out for those. Those will knock you on your ass. Some of them could be potentially lethal, so be careful when you get in there and start poking around with things, and never do it when it's plugged in to the wall. Ever! So, I guess that about wraps it up this week. For those of you hoping there would have been a CB750 cafe bike, whatever, this week, well, too bad. It's going to happen, but it's too damn cold in my garage right now. It's like 30 degrees out there. I can't really heat it up. So when it gets a little warmer one of these weekends, I'm going to get everything down off the shelves, look it all over, and get started on a video. And until then... Electric. There's a lot of yeah, a lot of, yep, that's what there's a lot of is very that.